Hello everyone, I'm Fei from ICT Chinese Academy of Sciences. Today I will give you the talk AIBench Training, Subsets and its Rankings. These are the other AIBench contributors. I will mainly talk about the following contents. A lack of understanding of learning dynamics raises serious AI benchmarking challenges, and AIBench training methodology, workload characterizations, two subsets for repeatable performance ranking, and workload characterization and rankings. Deep learning is a highly dimensioned non-convex optimization program. A slight change leads to a different optimization path, and the AI training heavily depends on the presence for hypermeter tuning. The prohibitive cost of training a state-of-the-art AI model raises a serious benchmarking challenge. Some mixed processing optimizations indeed improve traditional performance metrics like throughput. However, they adversely affect the final model's quality. We can only observe by running an entire training session, so running an entire training session is mandatory. Unfortunately, it is prohibitively costly, often taking several weeks on a small system. Furthermore, the architectural community heavily relies on simulations, with slowdown varying widely from 10 times to 1,000 times, which further exaggerates the challenge. There are conflicting benchmarking requirements in different stages. On the one hand, earlier stage evaluations of a new architecture or system need affordable AI benchmarks to reduce costs. Meanwhile, affordable benchmarks are also necessary to provide valuable performance implications. On the other hand, later stage evaluations or purchasing off-the-shelf systems need detailed evaluations using comprehensive benchmarks to avoid benchmarking. The benchmark's shelf life is short as the state-of-the-art models evolve very fast. However, it often takes more than 1 year to work through benchmark design, implementation, community adoption, and wide-scale testing. A synthetic benchmark like parrot DNA seems useful as it can traverse more neural networks. Unfortunately, it cannot model learning dynamics. An AI task's program scale is often fixed, which raises the scalability challenge. The current benchmarking practice shows the largest scale system can finish an image-led training around several 10 seconds, which cannot constantly stress the system test. HPL AI is scalable, but it cannot model the learning dynamics without considering the model quality. The benchmark mandates being repeatable, while deep learning's nature is stochastic, allowing different but equally valid solutions. The factors of randomness are model initialization, data argument, data shuffle, dropout, and others. AIBench training workloads have different run-to-run variations. Then, I will introduce some related work. Downbench is the first benchmark that proposes time to accuracy as a main metric, which requires training a model to state-of-the-art accuracy. AIBench is the first benchmark that notices the necessity of modeling the critical path of a real-world application scenario. MLPerf is a systematic AI benchmarking project that includes 7 benchmarks for training and 5 benchmarks for inference. MLPerf performs the most large-scale testing, but it fails to present a benchmarking methodology to justify the choices for and update AI tasks, models, and datasets. Besides, They fail to consider the conflicting requirements, shelf life, scalability challenges. PyroDN is a first synthetic AI benchmark. The HPR AI is a micro benchmark that uses mixed processing RU decomposition to achieve upper bound flops performance. It is scalability, but RU decomposition is not relevant to most of the AI workloads. Both PyroDN and APR AI cannot modeling the learning dynamics. Finally, I will introduce AIBench Training. AIBench Training adopts a balanced AI benchmarking methodology considering comprehensiveness, representativeness, affordability, and portability. Its methodology is as follows. Perform a detailed survey of the critical domain, internet service, including search engines, social networks, and e-commerce. Include as most representative benchmarks as possible. Propose repeatable performance ranking subset and workload characterization subset, and keep the subset to a minimum. Consider the 4 benchmarks, the subsets, and the micro benchmarks as indispensable. These are 3 internet service, search engine, social networks, and e-commerce, and their core scenarios and involved AI tasks. There are 19 representative AI tasks selected from 3 internet services and their models, dataset, and target quality. AIBench Training contains image classification, image generation, text-to-text translation, image-to-text, image-to-image translation, speech recalculation, face embedding, 3D face recalculation, object detection, recommendation, video prediction, image processing, 3D object reconstruction, text summation, spectral transformer, learning to rank, neural architectural search, advertising, natural language processing. Image classification is to classify an image into multiple categories. It uses an image light as dataset and uses ResLight 50 as the model. Image generation is to learn the distribution of images to generate new images. It uses LSUN dataset and the model is WGAN. Text translation is to translate one image to another. It uses WMT English German dataset and use transformer as a model. Image to text is to generate description text for given images. It uses MS Coco as a dataset and use a model, use CNN and R, use a model which is a combination of CNN and RN. Image to image is to convert an image from one representation to another, and it uses city space as a dataset and CircleGAN as a model. Speech recalculation is to recalculate voice messages and translate them into text. It uses library speech as a dataset. The dataset contains contains more than 1,000 hours of voice data and is the most representative audio dataset. It uses the DeepSpeed tool as a model. Face embedding is to verify a face by learning an embedding. It uses VGG Phase 2 as a dataset and Phase Light as a model. It is a representative model and based on the Google Knight style inception model. Object detection aims to find objects of certain target classes with precise localization in a given image. It uses VOC dataset, which contains more than 9,000 images, and it uses fast RCN as a model. Recommendation is personalized recommendations based on cooperative filtering. It uses movies as a dataset, which is a real-world movie rating dataset from IMDb, and it uses neural cooperative filtering model, or fundamental algorithm for recommendation. Video prediction is to predict the video frame after by learning the previous video frame. And it uses robot poaching dataset and uses the mutation-focused predictive model. Image compression is to reduce redundant information in image data and store and transfer data in a more efficient format. It uses image light dataset as an image classification, and it uses an RNN-based model. 3D object reconstruction captures the shape and appearance of a real object, which is a core technology of a wide variety of fields like computer graphics and virtual reality. It uses shape light as a dataset, and the model is a convolutional encoder-decoder network, which combines image encoder, volume decoder, and perspective transformer. Test summarization is to generate summaries for given test. It uses the GeoWord as a dataset and sequence-to-sequence model. Spectral transformer is to transform images such as spectral rotation and scratching. It is administered as a dataset, and it uses spectral transformer network as a model. Neural architecture search is to automatically design neural networks. It uses PTB dataset and efficient neural architecture search model. Advertising is to display the most relevant advertises to customers. It is cargo display advertising challenge dataset and deep learning recommendation model. Natural language processing is to train a language model, which we use for many tasks like translation and question answers. It uses Wikipedia dataset and the model is broad. Next, I will detail the workload characterization of AIBench training. AIBench training workloads are representativeless and comprehensiveless in many aspects, including algorithm behavior, system behavior, and microarchitectural behavior. AIBench training workloads also cover many different networks like CNN, ResNet, RSTM, GRU, Attention, and others. It also contains workloads for different data types, including text, image, audio, video, and 3D data. Among the architectural independent metrics, AIBench training covers more range than MLPerf training in flops, parameter size, and conversion rate. Among the architectural dependent metrics, including computation pattern and memory access pattern, AIBench training is more diverse than MLPerf training. AIBench training and MLPerf training are concurrent work. AIBench training has more diverse workload characterizations. Among the AIBench training workloads, there are different workload characterizations, and all of the workloads are different. AIBench training covers more hotspot functions than MLPerf training, which is more suitable for simulator research. Then, I will describe the subsets for repeatable performance ranking and workload characterization. We have the following requirements for selecting repeatable performance ranking subset, reflecting diverse model complexity, computational cost, and conversion rate, low run-to-run variation, widely accepted evaluation metrics. For the workload characterization subset, we select the minimal workloads with the most representative system or microarchitecture characteristics. Finally, we choose image classification, object detection, and learn to rank as a RPR subset. We use k-means to cluster all the workloads from the AIBench training and find that they are clustered into 3 different clusters. For the WC subset, we choose the most center workloads from 3 clusters. They are spectral transform, image to text, and speech to text. At last, we find some insights from AIBench training RPR subset. We use the AIBench repeatable performance ranking subset to rank the performance of GPUs and TPUs listed in the table. TPUs have significant performance advantages in image classification, but lack generality and do not support many models, like fast RCN and learn to rank, because they support limited TensorFlow operations. PyTorch is poorly optimized for TPUs because it cannot load data directly from Google Cloud Storage onto the TPU as TensorFlow does, and data loading is a bottleneck for the image classification task. At last, I summarize this presentation. First, I introduce 5 AI benchmarking challenges: prohibitive cost, conflicting requirements, short shelf life, scalability, and repeatability. Then, I detail the AIBench training methodology, workload characterizations, 2 subsets for repeatable performance ranking and workload characterization and rankings. Thank you for your listening.